Okay, this is a single slide section on electrical safety. Let's find the PowerPoint. And there it is. All right, electrical safety. You should be aware that a person can be electrocuted by touching a live wire while in contact with the ground. This is often due to frayed insulation that exposes the conducting wire. The ground contact might be made by touching a water pipe, which is normally at ground potential, or by standing on the ground with wet feet because impure water is a good conductor. Obviously, such situations should be avoided at all costs. Electric shock can result in fatal burns or cause the muscles of vital organs such as the heart to malfunction. The degree of damage to the body depends on the magnitude of the current, the length of time it acts, and the part of the body through which it passes. Current of 5 milliamps or less can cause a sensation of shock, but ordinarily do little or no damage. If the current is larger than about 10 milliamps, the hand muscles contract and the person may be unable to let go of the live wire. If a current of about 100 milliamps passes through the body for just a few seconds, it can be fatal. Such large currents paralyze the respiratory muscles. In some cases, currents of about 1 amp through the body produce serious and sometimes fatal burns. As an additional safety feature for consumers, electrical equipment manufacturers now use electrical cords that have a third wire called a case ground. To understand how this works, consider a drill being used in the figure. A two-wire device has one wire, called the hot wire, connected to the high potential 120 volt side of the input power line, while the second wire is connected to ground, which is 0 volts. If the high voltage wire comes into contact with the case of the drill, as in the top figure, a short circuit occurs. In this undesirable circumstance, the pathway for the current is from the high voltage wire through the person holding the drill to the earth, a pathway that can be fatal because it passes through his heart. Protection is provided by a third wire connected to the case of the drill, as shown in the lower figure. In this case, if a short occurs, the path of least resistance for the current is from the high voltage wire through the case and back to ground through the third wire. The resulting high current produced will blow a fuse or trip a circuit breaker before the consumer is injured. Special power outlets called ground fault interrupters, GFIs, are now being used in kitchens, bathrooms, basements, and other hazardous areas of new homes. They are designed to protect people from electrical shock by sensing small currents, approximately 5 milliamps and greater, leaking to ground. When current above this level is detected, the device shuts off. That is, it interrupts the current in less than a millisecond. That ends this section on electrical safety, 8.7. The next one is 18.8, conduction of electrical signals by neurons.